erode only up to a certain level, but under normal circumstances they will erode only up to the mean sea level, assuming that the river is an extensively large, slow moving, such that it cannot erode at all. Now, the second question, that we often find partially submerged elevations, that is that is due to the erosion of the sediments from the beds over there, and when we see them at higher elevation, that is due to the deposition of sediments over there. However, the change in elevation can be also due to plate tectonic movements, but with reference to the question, with reference to the erosion and the deposition of the sediment seems to be a very good answer. For the third question, the first one, which is showing a sequence of clay and sandstone deposits. Clay and sand is defined by their grain size. So what is happening basically, that when in the plains there was clay that is formed of smaller grain sizes, so it is getting eroded from there. A layer of clay gets deposited, and then while the plain is getting deposited with another layer of clay, there the sand is exposed of larger grain sizes. So again the river comes and deposits the sand. So basically we will get an alternate clay sand layer. The second one, for which they have shown a river flowing through a canyon. That one is because it cuts through the harder rocks, as we can see over there in the second image. Because it cuts through the harder rocks now, because it cuts through the harder rocks at the bottom, we can see a difference. The upper layers are basically the same, formed of sediments. The lower layers are formed of harder rocks. For the fourth question, the formation of the hypersaline lakes is because of the formation of oxbow lakes due to cutting of the rivers. So what is happening is basically that when the river is having a turn, so due to that turn, the angular velocity remaining the same, so the velocity of the river at the farther end will be higher as compared to the velocity over here. Now the river will be depositing more sediments at the place where it will be having lower velocity, because of which this place gets more and more sediment rich. However, the sediments are dissolved from the other side of the river, leading to a turning of the river, and ultimately the landform is coming in between to separate the oxbow lake. The formation of the oxbow hypersaline lakes is a possible explanation for the hypersaline lakes that we see around that time.
Very good attempt. So should I ask you some questions?
I guess IISER will get this done with their answer. It's directed to ISC. You have 3 minutes to present.
Okay, so the mean level of erosion of a river is determined, it's some sort of mathematical modeling which gives us a profile of the river's course depending on it is proportional to the total length of the river from source to bed, to the delta, whatever. This is the height profile. I don't know the equation of the model, but it looks something like this. This model can be used to explain the rest of the answers. I'll go first with the third answer, the formation of a canyon. In case there are tectonic activities in the course of, tectonic activities that upwell the land somewhere in the course of the river erodes through this sediment so that it reaches back to its original course. Similarly, that is how a canyon is formed. Similarly, for the other thing, we see large layers of deposition. That may be because of the opposite process, geological processes downwelling the land, and the river fills this gap again for coming back to its original profile, that is the base level. The fourth question can be explained based on the closing of the Strait of Gibraltar and the drying up of the Mediterranean Ocean. As the ocean was converted into a large lake, seawater was locked inland and it started drying. That led to the formation of the hypersaline lakes. So drying of the sea reduced the mean sea level. So essentially this graph went down and the river cut deeper to come back to its origin, to come back to this equation. In doing that, we find the 2 kilometer deep incisions. Also, since the delta moved a little further away, the graph would look a little more like this. So these regions saw more erosion near the delta than towards the source of the river. Yeah. Hypersaline lake, 2 kilometer deep incisions, base level canyon, this. For the second question, plains at high elevation can be explained again by land moving upwards, but instead, unlike the, say, a third question where these processes have happened rapidly and the river has cut through all of those layers of rocks or deposited all those layers of sediment, over here the plains have gradually moved upwards towards the mouth due to tectonic activity, due to continent formation or such processes, which is why the plains have moved up without causing severe erosion as happened in the case of the canyons.
I guess the presenting is done. IIT Bombay, you have 2 minutes to present now.
First question, I agree with IISER Kolkata's answer that it would be nearly at mean sea level, but I feel that they did not explain why it should be at mean sea level. So, if the base level goes below mean sea level, then there would be like water would tend to flow from sea or ocean into the river. So it would like decrease the flow of river, and then which should basically not happen. So hence the riverbed should be like nearly at the mean sea level. Then for the fourth question, hypersaline lakes are usually formed when there is no freshwater source coming into the lake, and instead the water is seeping into the lake through underground sources. So we have been told that the Nile River cuts deep during that time, which can cause like to more easily flow into nearby lakes, causing more formation of hypersaline lakes, which explains why we saw more hypersaline lakes.
Also, for the second, the base level is mainly due to what we think is that the soil composition changes as we go deeper into. So, at some point, the soil composition would be such that it would take a very long time to erode that soil. It is highly compact or something like that. So, at some point, the base level remains constant, and hence there would be some places where soil composition is such that the base level is very high, and hence the plains are at very high location, and sometimes it can be at low elevations. The other regions could be tectonic plate movements or deposition of soil, which causes the plains to be at high elevations. For the third question, the canyon is mainly formed because the soil composition is different at
IIT Delhi, you have 2 minutes to present now.
So I believe the base level of a place under normal circumstances should be up to the bedrock region. So the soil has 3 layers: the humus, topsoil and subsoil, and the bedrock. And I believe it should just be to the absolute elevation of the bedrock region. For the second question, we find plains at low elevations and at also some at high elevations. I believe the level of bedrock is different at each point, so it should not affect that much. That's why its elevation is independent. So
in the fourth question, I believe that similar to the one explained there, we see lakes that form due to the incision of rivers. What happens is the lakes are at a different temperature compared to the sea, and what happens is these lakes are usually at a higher temperature than the sea. So the rate of evaporation is much faster here. So due to the higher rate of evaporation, we find a large quantity of salt present in a comparatively lower quantity of water. So we see a higher concentration of salt here.
the reason for the higher temperature is because water is not moving here, it is stagnant, it is at the place and it's getting constantly heated. For the third question, I believe in ancient rivers the rate of deposition gets comparable to the rate of the base level change, due to which there was uneven deposition in it. And for the second diagram, the river is not that ancient, it's continuously flowing, due to which you can see It's like an almost even base change as indicated by the diagram. It's like almost like this, where the rate of deposition is not yet comparable and it might get comparable in the future.
The floor is now open to questions from the judges.
So if I understand correctly, we have to judge IISER Kolkata for 15 and ISC for 13, 11 and 9. Is it correct? Okay.
And there should be questions to all of them, or we just take their answer, or okay. Okay, you have any specific question to them? Okay, go ahead.
Okay, I will check this, the fourth question where you talked about Oxbow Lake. You know, because these are mostly connected to the coastal regime. So you have to expand more in direction of Oxbow Lake leading to hypersaline lakes.
So what is happening exactly is, since it is mentioned in the question that the Nile River had incised deep into the riverbed over 2 kilometers, what it means is basically that it is very deep close to its mouth, and mouth is the place where it interacts with the sea. So the ocean water can mix with the river water, and then
I'm sorry, are you changing your answer? You said something.
yeah, I mean, the Oxbow Lake formation is still our answer, but this mixing is happening, and then the Oxbow Lake formation is happening as per the mechanism we had explained previously, and so these lakes are hypersaline.
So then in principle you can find these Oxbow lakes in the continent also.
Yes,
So you have to find a reasoning why the hypersaline lakes are not in the continent but in the coastal region.
One more thing to add. Just your campus is surrounded by Oxbow lakes, right? You know that?
yes, yes, sir.
All the water bodies,
Yes.
if you look at them at Google Earth, are any of them saline?
No,
Why?
because when it is inside the continent, then because the sea water cannot mix with, I mean, there is not so deep incision for the sea water to mix. That is why they are not saline.
Thanks. Gyan, any-
I am also not very clear about your answer about this grain size fluctuations, the clay and the
So your explanation was there was somewhere up there you have layers of clay and sand and you erode them and deposit them here. You just shifted this question where you have sand and this thing clay to somewhere up there. How did they appear in the upstream areas?
So in the upstream areas, as clay and sand are determined by their grain sizes, what is happening is that the river, when it is eroding, it is first eroding, suppose the layer of clay. So
No, my question is in that place where it is eroding from, why do you have layers of clay and sand? In any place where deposition has happened, often you find these layers of clay and sand. Why their deposition?
we don't know.
Something to think about for you. I think we don't have any more question to you. Next is Bangalore. Do you have answer to this question? So how can you get layers of clay and sand at same place deposited by a river over some geologic timescale?
In this case, I have assumed that at some local spot in the river's course, there has been land submerging. As the land gradually submerges and the course of the river, as in the mouth and the source and the mouth are not changing.
No, we understand what you explained about
Yeah.
your model. My question is, forget about that. In general, in one place, how can you deposit layers of clay and sand over time? Same river at same spot, depositing clay, sand, alternate.
Deposition, the river erodes and deposits. Erodes from one place, deposits in another place. Usually what happens is deposition happens near the sea, where the river is too sluggish and it can't carry it any longer. in this case, it usually doesn't deposit in its middle or early course.
I mean,
In
these
this
things
case-
already you have explained. You just need to explain how can you get layers, alternating layers of clay and sand
Oh,
in this
alternating
process.
layers. Do you have any answer? No, but sand and clay are determined by grain size. It shouldn't matter what it cuts the material.
Maybe we take
I-
this
I'm
question
sorry,
to the
I
next
don't
group then.
have a
Yeah, you have any
conclusive
other
answer.
questions to them? Yeah. Next is IIT Bombay. Yeah. Do you have answer to this question?
Did not answer the third part of it, so we'll skip that. But your answer for the hypersaline was mostly connected to underground sources. How does a groundwater supply increases the salinity of a lake?
Yeah, so what we intended to do was that groundwater can come from either the river or the sea. So the water may contain, if it comes from the sea, it may contain some salinity, and also it is not directly connected to the river. So
If I understand your answer correctly, then you mentioned that no freshwater flow and underground sources.
yeah,
just
no
elevate-
freshwater flow means it's not directly connected to the river. So salinity increases as it evaporates, the left over there, but the water evaporates, and as water evaporates, the groundwater again comes into it. Salinity, it still contains some salt, it again groundwater again comes, it contains salt, evaporates, and as the salinity of the lake increases.
When you are supplying something from the groundwater, actually you are diluting the lake.
Yeah.
So the increase of salinity will be compromised if you are providing significant
No,
groundwater.
but the amount of salt will increase because that will evaporate. That water which came from the ground, it will evaporate. But that water will still contain salt. So the amount of salt in the whole lake would increase. And it would keep on increasing.
Yeah, groundwater would have less salt, but still, like when water is directly flowing from a river into a lake, that would contain even lesser salt. So groundwater would have relatively more salt than that.
You can always exchange salt with the lake. But precipitation cannot do that. Right?
I'm sorry.
Although it has less salt,
Yeah.
once it evaporates, its salt stays there. It doesn't get back to the atmosphere at any point.
Yeah. So
In groundwater, you can take the salts away and put them in the aquifer.
Well, repeat this. So no fresh water will help in increasing the salinity. Now that you have an additional source of groundwater, that will do the same job as a fresh water was doing. So having the underground water will not lead to a situation where hypersalinity is achieved. Okay, I don't have anything for IIT Bombay, but I'll just go back to IISc one more time. You have talked about subsidence in terms of explaining the fluctuation in the grain sizes actually.
Right.
Can
No,
you-
I couldn't explain the grain size explicitly. What I think can happen is the sediment being deposited comes from different minerals being eroded. Now, if the mineral is this is not something that I know, it is something that I'm guessing. If the mineral that the river is cutting through at a moment is harder, it is not able to erode it to a smaller grain size that would cause sands. If it erodes it to a smaller grain size, it causes silt. If it's a softer mineral, and if it's an even softer mineral, it can erode it even down to sizes of clay. That is the only thing I can think of at the moment.
It is not possible to have this kind of structure if it is homogeneous, source rock. Let's say it's all, some granite or something.
If it is homogeneous and if it is coming from the same distance apart, then I think it would be difficult. Magar, that's a guess. I'm not entirely sure. It depends on the time as well, or how long it has eroded in coming to that place.
because we do not really have an answer to this question, so everyone is thinking about erosion. Can the answer come from thinking about when things get deposited? Sir?
Sediments would be getting deposited, clay being smaller would go down and the sand would go up. But after some time, what would happen that the layer of the sand would be so thick that it won't allow further clay to go inside. The packing would be very like dense or tight, and then another layer of clay.
Not needed that hypothesis, but maybe you think about it along this line. The answer will be there. Thanks.
Okay, we go back to IIT Delhi. So what do you mean by level of bedrock in terms of defining the base level for erosion?
The bedrock is the harder region of the soil. So I believe that the free flowing water will only erode the layers which are not that hard in normal circumstances, and the bedrock region will take like very, very long time. So it will only erode some part of the top layer of the bedrock and not that much.
So mountains will have quite a bit of bedrock. Do you mean that the minimal erosion is happening in the mountainous region? What is your take on that?
So, like if the, so in like, can I take, taking an analogy of glaciers, when it melts, so the water keeps flowing down it.
Does bedrock erode or not?
Yeah, it erodes, yeah, that is. Huh? Yeah, so, but I still believe it would not erode to that extent. So I believe the erosion will be like, will be lesser than the bed, but the absolute elevation of the bedrock region will matter a lot. Like the bedrock region at different points can be different because it might be undulating too. So I think like at the end, it will mostly depend on the absolute elevation of the bedrock. There will be slight depth, but not that much.
About this, one more question that did not get answered fully: how can the base level in some places be high, like not equal to sea level? Okay, you gave some answer that was not very convincing. Okay, you said something about the plains moving up, but that will still make the bedrock remain at the level of the plains, which is the level of the set by the mean sea level. How can one have bedrock? Do you know of any place where base level, can you give an example where base level is very high? I want an example, not explanation, a quick example. It should be a geographical place.
The Gangetic plains are higher than the basin of the
The answer
European
should be
ones.
something like, Tibetan plateau. Okay, something which is really very high.
Yeah, but is that
Yeah, so think about it,
count
yeah.
as a plain?
Now think about it. Maybe you need to think about it. We'll stop the discussion here and maybe move to the next question. Unless anyone has any. You will explain the answer. Okay, explanations will come later. Okay, great.
Now we request a member of the question making team to present the correct answer.
So asking questions to Ekansh.
All right, so this is the general elevation profile of a river, and this is sea level. So because rivers flow due to gravity and they have to end up at sea level, they cannot erode more than the sea level, or they'll have to flow back uphill. Now for the second question, why you can find base levels at high elevations is, if at some particular points, say in this region, if you have uplift due to tectonic activities, that equals the rate of erosion caused by the river at this point, it will basically form a plane here and then it will modify the elevation profile of this river. Now, for the third question, for the first one, we can see that these are deposits. So this can happen when the base level of the river increases. Say the base level rises to here from here. So now the river has to flow all the way till here. So it has to deposit in these areas. So it will deposit and it will slow down because the gradient is decreasing. So when it slows down, due to the larger grain size of sand, it requires a much higher force. So when it starts slowing down, the sand will deposit first because it's heavier and it needs more energy to be carried, and then the clay will deposit. And then when all the clay is deposited, the sea level will rise. The base level will rise higher, and then again the sand will be deposited first. That's why you see the layers. In the second picture, the sea level, the base level, is decreasing. So the river has to carve out a deeper path, so it will erode all of this away. Now for the Mediterranean, we know that the Nile has carved 2 kilometers deep, so it must have eroded. Therefore, the base level must have gone lower in with respect to the continent. Now, because this has lasted only for a few 100,000 years, it cannot be uplift. And we know that hypersaline lakes are present. So this can happen when the Mediterranean dries up. So you have the same amount of salt, but less amount of water concentrated in a few regions. So you'll have hypersaline environments. So that means the Mediterranean must have dried up. And this can happen if you notice that the Strait of Gibraltar, which connects the Mediterranean to the Atlantic Ocean, if that gets closed, there is no water inflow into the Mediterranean and it will evaporate and dry up. So that's basically what happened.
Hello. I think it will be useful if you display the question there when the explanation is being given. Thanks.
IC chose the second question. All math is either number theory or shapes, and they say number theory. Please note that this question has two unrelated parts. Solving them in order is not necessary. You can continue with part 2 even if you can't solve the first part. Part 1. Canada has a lot of lakes, like a lot of them. Lakes are formed when water can't flow downhill and pools up. That is, the drainage system is disturbed or deranged. Just like water pools up on sides of roads with poor drainage. Shown here. Question number 1. How do deranged drainage landscapes turn into landscapes with dendritic drainage over time? Why is Canada's drainage system so deranged? Question 2. Why is Canada's drainage system so deranged that water has to pool up in so many lakes? Think of what could have blocked the processes in the first question from happening in the past. Question 3. An unrelated study in a different part of the world found that the place rose up in elevation during the drought years. Why did this happen? Think about how the same phenomenon that caused this place to rise up can disturb the drainage of the Canadian landscape. Part 2. From the images displayed after, please find the hiking stick in the first image for scale. These polygons are few meters in diameter. You will observe rock piles arranged in a polygonal pattern with diameters of a few meters. These are situated in Canadian regions that are seasonally frozen. That is, they undergo an annual freezing and thawing cycle. Next. Question 1. Draw and explain the graph of temperature of soil versus time of the year for these regions at surface, depth of 0.5 meters, depth of 1 meter, and depth of 2 meters. Question 2. Is the soil density higher during the seasonal freeze or higher during the thaw? Thaw equal melting. And why? Question 3. Using the answers to the above two questions, answer how the polygonal rock pile patterns in the above photographs form. Hint, think about convection. Question 4. Given a uniform flat surface, what shape would these polygons be? Question 5. Hazard a guess about why polygons are only a few meters in diameter. I see. Do you want any clarifications about the question? So your time starts now.
I see you have 5 minutes left.
One minute remaining. time's up. I see you have 5 minutes to present. Time starts now.
Starting with the first part, if we assume the deranged system happens when lakes are formed that are trapped by the land surrounding to them. After a point, if the lake gets too filled up, it can lead to two things: either direct overflowing, or it cracks the it cracks the bedrock under the huge weight of the water. Either way, it would erode through the system, erode through its surroundings, and lead to the formation of the dendritic system, where it leaks through every possible channel that it can find to reach the sea. This is the lake, these are the dendrites. About Canada, I would like to start with the third question here. We know during the ice ages, Canada was under a deep ice sheet. This ice sheet caused the mantle underneath to buckle and bend, and this downwelling of the mantle is still being reversed till date, as we have data that we have measurable data showing Canada's land is still coming back from this buckling. That has created certain it has created this has trapped the glacial water. Some of it has obviously flown back. There are still remnants of those huge lakes, similar to what happened in California, where we had that huge lake melting out and we still had some water left that was gone for anthropogenic reasons. But yeah, that water is yet to leak because it has still not eroded its surrounding. That is why we still have some deranged systems in Canada. What we say, place and think about the same phenomenon. I think that answers it. Derange the pools. Yeah, so the downwelling of the mantle blocked the lakes for quite a while, and the process of it becoming dendritic is still underway. It's not complete. For the second answer, I would like to start with the other parts, with the second part particularly. The soil density would be higher during the annual freeze, when at least at deeper levels, where the weight of the ice pushes onto the soil, makes it denser. The denser soil would also, the compression would also increase the temperature of the soil. About the graphs, the first one we see, it almost follows the dotted line represents the atmospheric temperature. It almost follows the atmospheric temperature, except right before the thaw, where the ice melts due to extracting latent heat from the soil. So there is a dip in the soil temperature. Also, because of the compression that I just mentioned, the soil temperature is a little higher in the deepest time of the winters. In time B, because it's deeper, the seasonal changes in the atmosphere don't affect the soil quite as much. So we get the difference is a little lower. Also, because it takes time for the heat convection to happen, the peak will be shifted a little. Similarly, for 1 meter deep, where the peak will be shifted further than when compared to half a meter, also the difference will be yet smaller. If we go deep enough, the atmospheric temperature changes should not affect the soil temperature, or at least its effect will be overridden by the effect of ice pushing the soil, compression making the soil hotter. So we get a reverse sort of a graph at 2 meters. For the third question, what have you done? For the third question, ice, as I said, extracts latent heat from the soil, and that leads to the formation of convection cells. The debris that has accumulated over the summers in these places gets pushed along with the convection to the edges of the cells. That would explain the formation of the rocks at the boundaries. In case of the polygons should be, the convection cells should ideally be circular, but since circles don't close pack, the closest shape, the closest packing is in the case of hexagons. So we get hexagons, the shape of the polygons would be hexagons, and why it is a few meters in diameter, I can only guess that is due to the characteristic of ice, which depends on factors like viscosity, on density, on which all factor into the Rayleigh number, how the convection cells exactly form, how much degree of partial melting and extractor dictate the size of the convection cells.
Time's up. IIT Bombay, I have 3 minutes to present.
For the first question, how are the deranged drainage landscapes converted into dendritic? So this could possibly be due to the erosion due to the standing water. So the standing water after getting collected over there creates a pressure on the sides due to which it erodes and converts into the dendritic pattern. And why is Canada drainage system so deranged that it is not able to convert into dendritic is mainly because of the alternating snowing and the melting seasons that they have, because of which the water gets frozen and the water is not able to erode the soil that well, and it keeps on getting collected and does not form the dendritic drainage. And during the drought years, all the sediments or the minerals that were dissolved in the water get deposited, due to which over the years this deposition increases and it can lead to an elevation in the ground.
So for the first question of second part, we have a graph very much similar to theirs. In the summer season, it would be higher temperature, and in the winters it would be lower. But as the deeper we go, the effect would be much lesser because it's much deeper into the ground, and the change in temperature is mostly happening due to atmosphere. For the second question, the density would be higher when it's the seasonal freeze, simply because rocks would contract slightly and it would cause density to be higher. For the third part, we have we have kind of these rocks in the center, which would during the seasonal freeze would get colder. They would try to come down, and convection sort of thing would happen, and the rocks which are at the bottom are warmer, so they would come up from the side. For the fourth one, similar to the convection best happens when it's kind of a cylinder, so there are only 3 shapes which completely tile the plane, in which hexagon is the closest to a circle. So hexagonal packing would have, we would see polygons of hexagonal shape. For the fifth part, why there are only a few meters? Because if they would be much larger, then these rocks would have to go way farther to come up, which would be kind of difficult, because after all, these rocks are solid bodies. Convection cannot happen that easily in this. So the polygons cannot be much larger. And in much smaller case, again, convection won't be that good. So the polygons are only a few meters.
IIT Delhi, you have 2 minutes to present now.
Yeah, as rightly pointed out, for the question 1, it might be due to the erosion of the land in which the water has been accumulated. For the question 2, the Canada surface is highly rough and terraneous because of the previous melting of glaciers and ice, which has made surface very rough. And in this, the water can accumulate, and there's so much deranged drainage in Canada.
So my explanation I am starting with part 2, first part. Yeah, I agree with these graphs for A, B and C part. And for the D part, yeah, this I believe this graph is correct, because due to the snow, so what will happen is the ice will go on top of the soil surface and it will give an insulating layer, much like the snowball state, which can happen on Earth. So which had happened in the ice age, due to which the temperature of the soil beneath for the 2-meter part will increase a lot and will not be affected by the temperature of the soil at the surface.
in the second part what will happen is, if we can see the that water in the river might seep into the cracks and the holes of the river bed. So when this happens, and when this water that seeped in freezes, the water expands. So due to this expansion, the river bed below it or to the sides must be compressed because of the expansion of water.
IISER Kolkata, you have 2 minutes to present now.
Okay, so for the reason for the conversion of this deranged system into the dendritic system is that when the river is suppose flowing into an uneven surface like this so it is going to form pools of water due to stagnation of water, but as the river is flowing, it is actually carrying sediments with it, which is going to deposit in this stagnant lake, and which time these sediments are going to pile up, and it is going to split the stream into many parts. The reason for Canada's drainage systems to be so deranged, this can be inferred due to the extremely uneven landscape of Canada, and the land rising in the different part might be due to the aerial deposition of sediments in various parts. So for the second part, what we can see over here is that at the surface, so this is a 0 degree. As we move deeper, it increases to 4 degrees Celsius, the temperature of water. So initially we will get this spike in the summer around the June-July region, considering Canada is in the northern hemisphere. But as we move down, so the difference in the layers of the water, the temperature will be reducing. For the second question, the soil density would be higher during the melting phase, because in the seasonal freeze, what is happening is, due to the anomalous expansion of water, the soil particles would be more gaped up due to the hydrogen
IISER
bonding.
Kolkata, your time is up. The floor is now open to questions from judges.
So to IISc, you said something about when this you had this deranged drainage and you want to turn it into a dendritic. You explained it mostly in terms of erosion, for which you draw some picture, whatever it is. But mainly it's erosion. Somehow you are managing to do that. But can deposition, or does deposition play a role?
Deposition can fill up some parts of the tract, essentially creating the extensive system of tributaries, wherein the rivers move a little away from each other, probably like from the same lake. If there are several tiny streams emerging from the same lake, them depositing between their paths, creating.
Okay, I get your answer. There's another thing you mentioned, that you talked about large lake. Okay,
Yeah.
but here it says Canada has a lot of lakes, like a lot of them.
Yeah.
Are you thinking about lots of large lakes?
No. During the last glaciation, when there was kilometers of ice, when it melted, most of the ice, flowed away to the sea. But some.
What you already explained, you need not explain. We understood your picture that you have ice sheets and it's been taken out, so it is coming up. And it got depressed. All that is fine.
Most of it would flow away, but the water would be left in pockets where the mantle hasn't come back up yet, where the crust hasn't come back up yet. So it would be in pockets. Numerous
so what would be the size of those lakes?
Sorry?
What would be the size of those lakes?
Pretty small, not large lakes. It is the residual. It is the residual small lakes.
So how do you define the entire lithosphere and create small lakes? That's the question. What you were saying is, when it comes to mantle and all that, because these are very viscous systems, they only work in very long wavelengths.
Right.
Right?
Uh,
Yeah, something
I
for
don't
you
know.
to think about. And do you want to add anything to this question 3, part 1? That somehow everyone has skipped during a drought year, why the land moved down or something like that. Moved down, right? Oh, sorry, rose up.
It could be something to do with the seepage of water, but I'm not entirely sure.
Thank you. I don't have any other question for you. Okay, who was the next team? IIT Bombay. So do you want to take up their answer and correct it, or maybe modify it? So this question of how can you get so many lakes in that area, which are probably small in size, large number of small lakes, related to the fact that these were covered by ice sheets. I don't think you gave a clear explanation for that, but maybe with that hint you can give it a try. Okay, and you tried answering another question about the size of these features, right? That's your answer, right? And you said, yeah, you were talking about it. You said it's very difficult for the rock to go horizontally more than some distance. And it's very difficult for it to do that less than some distance. What controls that distance? Why that distance is few meters?
Like, I can't really say why it is exactly few meters, but what controls the distance can be.
So what controls the size of a convection cell? If we assume these are due to convection.
It can be like the material of rocks, like which kind of rocks are there and their shapes, sizes, because if there is some kind of like rough material, it would hinder it from going much farther.
So in the first part of the question, you talk about the temperature varying with depth.
Yeah.
Can you relate it to that? Up to what temperature the seasonality is felt? Up to what depth the seasonal temperature variation and freeze-thaw cycle operates? Okay, something for you to think about. Then IIT Delhi. Do you want to take up any one of these two questions and answer it now based on the hints you received?
I believe the lakes are formed due to, like, as we can see, the place rose up in elevation during the drought years. So I believe that due to this phenomenon, the places will, so what will happen is that as water can't flow downhill, that's why the elevation increases. It's like if it is like a sloping pattern, the elevation at the bottommost point will increase a bit, due to which it will not be able to flow properly and it will pool up, causing these deranged drainage patterns.
So could you just take one more, maybe 5 seconds and rephrase this and spell it out clearly?
Okay.
I think you are maybe there, but this.
So the phenomenon is that this place rose up in elevation during the drought years. So in the drought years, what happened is that we can see that the water is flowing from uphill to downhill. So the downhill portion
to explain the lakes, are you bringing in drought years?
I was explaining the first part, like why is that?
Yes, but what's that got to do with the drought years? Maybe it has got something to do, but can you explain clearly?
So during the drought years, the river contains some kind of sediments, and I believe that when the river dries up, it deposits all the thing that is present in the river on on the bed of the soil, river bed.
So then why did these lakes form? Like, it's because of a perpetual drought or something, or recurring droughts?
So
And why is it not happening, let's say, here in Maharashtra, where there is a lot of...
wait. So like Maharashtra has like the Western Ghats, and I believe that they don't have that. They have a proper like elevation for the water to flow through, and I don't believe that Canada has something like that structure. Like I believe Maharashtra has Western Ghats which have a proper elevation.
I
because water
really
flows.
request you to go to Google at some time and look at these lakes. They're really spectacular. Yeah. No, I thank you for your answer, for your attempt. Maybe we move to the next group. Yeah. So you did talk about deposition. So can you explain when you could talk about how this, drainage structure where you have a lot of pools and lakes slowly can turn into a more dendritic river network? You can just use the words. No, you can just tell us. No.
Because due to deposition, the primary reason for why the lakes were being formed is that due to this uneven landscape, and the water was getting stagnant in those lakes. But the river is actually still flowing above, as we can see in the diagrams. That the river is still flowing, but suppose during the sediment deposition, as the water in the lakes is kind of more stagnant, so the sediment deposition will be much more efficient there, and due to that lake part,
It will fill up the depression.
that will rise up.
But then the question is, to start with, as you explained, at least because of deposition and maybe also because of erosion, this network, they will tend to go from this deranged state to a more dendritic state. That's what they want to do. So how come we have at present, it's a slightly different question,
Okay.
how come we have a deranged network today?
We have a deranged network today. Okay, this might form due to like re-erosion. Like it is a kind of a system, like when the things are getting deposited over here, so in certain regions due to certain geographical like after the leveling
No,
has
we are
happened-
talking about a specific region. So can you give me a specific answer if you have one in mind? And think about the clue that you got from IIT Delhi. They're talking about whenever...
Okay, we have a deranged system today because
And also from IISc. The ice sheets are doing something and the slopes are... Yeah.
his shits are doing something, because we know Canada's climate actually. So over the layers of the soil there are ice sheets forming and melting. So the soils, they are getting weakened and cracked once again. So
Okay,
so
maybe,
this-
maybe you need to think a bit more about it. Okay, we'll answer this now. Yeah, I think we are done with the question answer on this. Thank you.
You did not comment about the shape.
About the shape of these polygons and their size. You want to add anything to that? The discussion that has already happened. You need not repeat anything.
Yeah, like the polygon, like using that temperature profile and the soil density being higher during the thawing phase, what we can say is that
So why soil density would be higher during thawing phase? Can you explain that?
because that melting already, and when it is melting, the ice, we know that due to the anomalous expansion of ice, so
Thank you. Yeah. And then
so during the freezing, ice was occupying more volume. So because of a more volume, the soil particles are placed farther away. So the density.
so density would be low. Then what happens?
Then now it melt. So 1 degree, 2 degree, 3 degree, and up to 4 degrees Celsius, it has the highest density. So because of that, now the water, the soil particles inside the water are at a much lesser distance, and so it is occupying a much lesser volume with the
So
same.
people have already explained that may will lead to convection, and then what is the size of those cells and shapes.
And the size of the rock.
Temperature gradient is not a length. We are looking for a length.
But that gradient is
Trying to understand why these sizes are few meters, maybe couple of meters. Okay, think about it, all of you. Anyone wants to add that answer quickly, why the size is few meters, based on the discussion that has happened? Okay, thank you.
We request a member of the question making team to present the correct answer on stage.
So for the first question, how do deranged landscapes turn into dendritic landscapes over time? Is this on? Oh, okay. IISER Kolkata got it kind of right. In the lakes which are low-lying, any low-lying part, the water will slow down and it will deposit sediments, and any high elevation it will get eroded. So over time, this irregular elevation will get leveled out by the streams themselves, and the deranged landscape the streams will automatically align themselves and sort themselves out into a dendritic drainage. Why is Canada's? Yeah, so you guys got it right. There were ice sheets present which blocked the surface, protected it from erosion for a while. Also, the ice sheets carved out the surface, made the topsoil bare. So now the topsoil is gone, it's just bare rock, which is also harder to erode. And also they added weight to the whole thing. So it got pressed down, and when the ice sheets went away, the land started rising again. So that's called isostatic rebound. You kind of mentioned it. Okay. In the third question, why is the land rising up during the drought? It's just that the weight of the water is now gone. So there's no more. So you lifted weight from the system, so it's rising up again. And how is this? What? Yeah. And how is this disturbing the Canadian landscape even more? So the Canadian landscape is still rising up after the post-glacial rebound. And so if you have a river that's flowing and suddenly you are elevating random parts of it, it will get more deranged. Yeah. For the graph, this graph is right. So it will just be this graph will be the atmosphere. This is high temperature in the summers, low in the winters, and at some depth, the amplitude will be lower, but it will be shifted to the side a little bit. And as you go deeper, the amplitude decreases and the lag increases. So basically what I wanted you to get at is the lower layer in summers, the lower layers will still be frozen, and in winters, the lower layers will still be hotter than the surface. And second one, soil density is higher during the melting because water is denser than ice. So yeah, that's it. And the third one, what you have in the winter is, so in the winter, let's say now winter is ending and summer is about to start. The top layer starts melting, but the layer underneath is still frozen. And now this layer is getting denser than this layer. So convection starts happening here. This lighter frozen layer is going up. This is moving away. And now convection starts happening. So convection cells are basically set up in the soil. And now if you see the surface of the soil, any rocks on the surface will get pushed in these directions. The soil acts like a conveyor belt which carries the rocks to the edges of the cells, and this piles them up on the edges. So when you look at a top view of this, you'll see the cell pushing rocks radially outwards. And when there are many such cells side by side, You'll have something like this with the rock piles happening on the boundaries of these cells. And if everything were uniform, this would obviously be a hexagon because these guys want to be packed as tightly as possible. And why are the polygons only a few meters in diameter? That just has to do with the properties of the soil, how much it can flow and all. And a reasonable guess might be that since the depth is only a few meters, the width will also be in the same order of magnitude. So that was an open-ended question just to see what you guys come up with. Yeah, that's all. Thank you.
Thank you, Raj. Just a reminder to all teams that while passing on the questions, adding on to the answers will award you points, not repeating them. That's just wasting time, really. ID Bombay, you are directed to the next question. Which one would you like to choose? Food. Question number 3. Food. On Earth-like planets, scientists Mary and Bedha realized that an extinction event was underway in deep ocean regions. However, they were unable to obtain deep water samples and only had access to the shallow water. In the sediments here, they discovered that the recent pyrite sulfur 2 minus deposits had a higher sulfur 34 to sulfur 32 compared to pyrites under normal conditions. A few facts are known. First, pyrite formation in deep sea preferentially takes up sulfur 32. Number 2, currently on Earth, most sulfur in deep ocean is sequestered as sulfates rather than sulfides. Number 3, a little catfish also whispered in Mary and Bedha's ears that the FeHR to FeT ratio was uncharacteristically high in the deep ocean. Here, FeHR is the amount of iron present in highly reactive forms, and FeT is the total amount of iron. Question number 1. Why are recent pyrites enriched in sulfur 34? Question number 2. What does sulfate to sulfide sequestration ratio tell you about the composition of the water? Does the FeHR to FeT ratio being high support your answer to the second question? Question number 3. And now, why do you think the deep ocean organisms are dying out? Mary and Bedha still needed to figure out why this was happening in the first place. They further know the following things about the planet. First, a recent glaciation event has occurred and our continents are covered in ice sheets. Second, deep oceans near continents seem more affected by the ongoing extinction event. Third, phosphorus fixing processes are most active up to 200 meters of depth. Fourth, Mary and Bedha are in an equatorial region and the continents nearby aren't glaciated. Question number 4. How do you think the recent glaciation event is connected to the extinction event? That's it. Your time starts now. Oh, do you want any clarifications, Andy Bombay? Time starts now.
5 minutes left. One minute left.
Time's up. IIT Bombay, you have 5 minutes to present. Take this. Time starts now.
Yeah, so we know that we have a relatively high concentration of S34 to S32 in the recent pyrite deposits, with which we can infer that a similar abnormal ratio should be found even in deep oceans, and that pyrite formation in deep ocean preferentially takes up S32, so leaving even more S34 for sulfates, and S34 is more radioactive than S32, which causes more radioactive sulfate, and high that the iron is present in its more reactive form also supports this, because iron would easily react with sulfates rather than sulfides, and while FeS precipitates in water, so it won't cause much of a problem for ocean organisms, while FeSO4 dissolves in water, it can create the water toxic for ocean organisms, especially deep sea, because the water in which FeSO4 is dissolved would likely be heavier than normal water and would go towards near to the ocean bed, and this is why, due to higher toxicity of deep ocean, the deep ocean organisms are dying out.
For the fourth question, the glaciation has caused the water runoffs to stop from the land to the ocean. So all the minerals or the phosphorus content that was supposed to come from the land has now stopped. And as they have told that phosphorus fixing only takes up to 200 meter, the essential nutrients or the phosphorus that was coming is no longer available in that much amount to the ocean organisms, and that's why at the deep level the ocean organisms are dying out, especially near the continents that have undergone glaciation.
So for the first one, we agree that it is clearly mentioned that the deep sea ocean preferentially takes the S32, leaving out the S34, which is used up in the pyrite formation at the surfaces. So that explains that recent pyrites are rich in S34 because they were only able to collect the samples at the shallow water level. For question 2 and 3.
Yeah. So in question 2, what happens is, from the fact that the sulfate to sulfite sequestration ratio is high, we can conclude that the sulfides are being oxidized more easier relatively. So this tells us that the concentration of dissolved oxygen is higher in these waters. Yes, the ratio of Fe highly reactive to total Fe is high due to the same reason. So this supports our answer. And we think that the deep sea ocean organisms might be dying out because the sulfides that are in the sulfides that are in the FeS at the deep sea is being oxidized in the S34 form more easily. So so the S34O42- form is being taken up by the fish, and this causes the radioactive sulfur to be to get into the fish's system.
Yeah. And for the fourth question, due to the glaciation, the oxygen gets trapped in the ocean basin flow, and it is not consumed since the phosphorus fixing processes is only up to a depth of 200 meters. So over the years it gets accumulated, and the process continues like explained the question.
we would start with question number 2. So, as we know that the sulfate to sulfide sequestration ratio tells us about the pH of the water. So, if the sulfur is getting oxidized to sulfate, then it must be in the acidic medium because the electropotential in the acidic medium for the oxidation is significantly lower as compared to the alkaline medium. So that means in the deep ocean region, the water is more acidic as compared to the shallow region where the water is alkaline. Now, does the NPHR by FET ratio support our answer? Yes, it does support because again in the acidic region, iron remains in the more reactive equilibrium rather than in the epithelial. Now, why the deep ocean organisms are dying out? Simply because the organisms need equilibrium in order to survive. But because of the sequestration, now the sulfate it is coming down. For the oxidation of sulfur or sulfate, the iron filter is getting reduced to equilibrium by taking out an electron. So because of this, now every SO4 is being formed, iron sulfate is being formed, which is why I think the deep ocean organisms are dying.
So, but the deep ocean is not receiving that. So we can assume that since most of the resources, the sunlight, everything goes from above to below, the upper layer of organisms could be out competing the lower ones for these nutrients. So lesser nutrients would be going to the deep ocean. So the organisms in deep ocean could be dying.
Okay, I would like to start with start my explanation with how the glaciation is changing stuff. We know that the oceans get a constant supply of minerals through erosion of the continents. In case of glaciation, this erosion gets slowed down. So deep oceans ka mineral, the influx of minerals into the deep ocean is disturbed. This changes the ecosystems and that causes an initial dying out. It could also lead to such a mineral composition where only certain bacteria, in this case sulfur reducing, in this case, sulfur bacteria would proliferate. These bacteria would convert sulfides to sulfates. And because they are biological organisms, sulfur 32 is more readily converted than sulfur 34. This increases the proportion of sulfur 34 left behind in the sulfate form, explaining why pyrites take up more of that. Also, since this oxidation happens, it increases the amount of iron in its stable forms, the ions being reduced to atomic iron. Yeah, that's about it. Organisms are dying out initially because of the lack of minerals. Also, it's mostly happening in the deep oceans because the shallow ocean can supply its phosphates through biological and other processes, whereas the deep ocean relies more heavily on erosion of phosphate-containing rocks from the continents. And the dying out is aggravated because of these bacterium proliferating.
The floor is now open to questions from the judges.
So we start with IIT Bombay. So what is this radioactive sulfate and why that will be controlling the productivity? What do you mean by radioactive sulfate? Do you think 32 or 34 is radioactive?
S32 is more naturally occurring, so I believe S34 is slightly more unstable than S32.
No, you mentioned that radioactive sulfate will lead to a iron sulfate and that will have a lot of radioactivity and that
No,
could
like
lead
in
to...
general, we will have iron sulfate, and in that also the S34 composition, S34 to S32 ratio would be more than what it normally is.
So this radioactivity is not something that you wanted to say, because you mentioned something related to radioactivity. I don't understand
Like,
what this is.
first of all, FeSO4 would make it toxic for the organisms, and then even in that,
Those are fine. So
yeah.
do you stick to this word, radioactivity?
Is sulfur isotopes 32 or 34, any one of them radioactive, you think? And is that important for this question or not? That's what he's asking.
It's not much important, but I guess it can have a slight difference. S34 is slightly more radioactive.
Okay, so one of them is radioactive.
Yeah.
I mean, this is a yes or no, right?
Yes,
There's
yes.
No, slightly or.
Yeah.
Okay, thanks.
I don't think any of them is radioactive actually. 34 or 32.
S32 is not S34. I guess maybe I'm wrong.
Maybe you can take his word that none of them are radioactive. Would you want to change your answer?
Okay, then I guess radioactivity won't play anything, and it would just be that FeSO4 is toxic to organisms when it goes inside the system.
So what is your take on the sulfate to sulfide ratio, and what is the composition of water? So from the total discussion of your, I could not understand. You mentioned that there will be formation of iron sulfate, which may be radioactive, which now you're mentioning about as toxic. So how that is driving the sulfate to sulfide ratio, and what it talks about the water composition? That was not clear from your answer.
I meant to say that deep, the opposite, like sulfur. There is more of sulfate. That's why iron sulfate would be formed more. Like there is more sulfate and more iron in the highly reactive state. That's why more FeSO4 is formed, which is going inside the
What it
systems.
refers about only about FeSE4 presence, or water composition means whether it is what do you infer about the water, whether it is a highly saline, redox, or acid, or what did you understand from the sulfate to sulfide ratio about the water composition? That was the
It
question.
would be acidic kind of.
When can you expect to get pyrite?
What?
Positive. What is pyrite?
Fe. Yeah, FeS.
When do you expect it to get it?
It would, like, it precipitates out in water, and so it would get deposited on the ocean floor.
What type of water?
Any precondition for pyrite to get deposited?
Yes, in acidic water it would
Now you're
deposit
guessing it. You
easier.
must have a reason to say that.
No, I don't know any specific
Okay.
reason.
So then you also mentioned about the continental shelf glaciation and its drive on the ocean, organism dying out. What do you mean by that? You mentioned that during glaciation, the continental shelf region, you will have a different situation that will lead to dying out of organisms.
One more question to this. You said something about fixing of phosphorus. What is this fixing, if you could explain it to me, for me, okay, apart from answering that question? I think this was part of your answer to that point.
So basically, because of the glaciation, suppose the minerals and the phosphorus from the rocks, basically the phosphorus cycle that is happening at the continent level will not be able to reach the ocean because of the water runoffs. Because of the glaciation, basically the water has been frozen, so there is no water runoffs to the ocean. So now the phosphorus cycle is only limited to the upper levels of the ocean, and the content of the phosphate available for the plants or the animals to intake is lesser. So because of which the organisms start to die.
Still not sure what you're referring to, because you will have a surface layer, and because you have a glaciation, unless you tell me, I'll come back to IISc for that, unless you tell me for some reason there is a lack of erosion, phosphorus is not reaching to, open ocean. Open ocean, if you have phosphate, the life will survive. Why there will be a mass extinction based on glaciation?
Because phosphorus cycle is like a sedimentary cycle. It happens, the reservoir of phosphorus is mainly rocks. And because of the glaciation, the rocks and the all of them are basically below the glacier, so they're not able to be eroded and reach the ocean level.
What is your take about this highly reactive iron to total iron? What is this ratio? Okay. What do you mean?
The reason for it, are you asking for
What
the
is this ratio itself? How this will be useful in tracing anything related to water composition?
Yeah, so mainly I think because highly reactive Fe will react more with FeSO4 because that is more reactive than sulfides.
You rarely, to be honest, I can tell you this, you rarely find iron sulfate in the, continent. You don't find iron sulfate in, if you see minerals, you rarely find iron sulfate actually. Okay,
Then maybe I'm not sure.
sure. I'll move to IIT Delhi. So you mentioned that the sulfate to sulfite ratio is something to do with the oxygen condition, and that is also related to the radioactivity of sulfate, this oxygenation, radioactivity and sulfate. Can you explain that? What is first radioactivity is something?
Sir, I was under the misunderstanding that sulfur 34 is radioactive. I would like to change my answer. So now that since the water is now acidic and has a lot of oxygen content,
How do
what
you
we
know
can
it
say
is
is
acidic?
what?
How
Sorry.
do you know it is acidic? You mentioned
Yeah,
that now
from
it
the
is
fact
acidic.
that the ratio of the sulfate to sulfide is higher, we can say that sulfide is easily getting oxidized to sulfates, and this is more likely to happen in acidic conditions. So we can say that the water is
It
a bit
can
more
lead
acidic
to
now.
a acidic situation, but oxidizing a pyrite doesn't mean that the water was acidic. I mean, you can oxidize a pyrite to form acids, but it may not be starting with a acidic water column.
I think it became acidic over time due to sulfate formation.
Yes,
That
but
is what I
we
believe.
already have a situation where we have a high sulfate by sulfide ratio. What does it tell about the water composition?
So, as mentioned in the later part, due to the glaciation over many years, the oxygen gets trapped and it consumes all sulfides and converts into sulfates. So,
No, why glaciation will trap oxygen?
uh, it, because of the high pressure, it doesn't let it go outside, and oxygen is also not consumed because the phosphorus fixing processes only occur in up till a depth of 200 meters.
So you need to appreciate this, that the oxygen content is so abundant. So just a glaciation of a few percentage of area will not lead to a large scale change in the atmosphere oxygen level. If that is not happening, the availability of oxygen is already there. So
I think it will be useful if you can just tell us how oxygen is entering the ocean and what is its profile, and these two processes, I mean these few processes, how they are operating. If you have a clear picture and if you clarify to us, maybe that will be useful. And if you don't have a clear idea, you can pass it on. That's all right.
so next question is, why do you think deep ocean organisms are dying out?
Yeah, so now that the percentage of sulfates is a lot higher, we can the sulfate gets soluble in in the body of the fish, and this creates this creates a high sulfate toxicity.
Sulfate is not toxic. We have lot of sulfate in the river water itself, which we are drinking.
the higher sulfate to sulfide ratio at the end signifies that the water is getting too acidic for the organism to survive. I believe that.
And what is your take on the glaciation and its impact on extinction event?
I don't have a clear explanation for that.
Okay. Okay, I move to IISER Kolkata. So, you mentioned that deep water and the consumption in the surface lead to a FeHe4, where this transformation of iron to Fe plus 3 to plus 2 restricted the biological activities. Explain that.
So what I'm saying is basically that the sulfate to sulfide sequestration is giving us a hint that the water is acidic because the electrode potential for this oxidation in acidic conditions is much greater as compared to otherwise.
So, I can tell you that if you have a high sulfate to sulfide, so that means sulfate is there, sulfide is low, that can lead to a higher ratio. If sulfides are low, then you are not producing sulfuric acid. So I may not be able to directly talk about the acid of water unless you give me a better explanation for that. Sulfate doesn't it doesn't control the pH of water.
No,
Mostly sulfides can, provided they are not in a sulfuric acid kind of situation. So because that has to be low to talk about acid. So if you're talking of acid, you have to give me a proper reasoning how sulfate by sulfide can talk about acidicity of a water.
So it is like, I'm not saying that because the sulfate is being sequestered, that is why the water is becoming acidic. I'm saying because the water is acidic, now the sulfur is getting oxidized to sulfate. So the sequestration
How
ratio.
do you know water is acidic?
Huh?
How do you know water is acidic?
Because thermodynamically this oxidation is favored in acidic conditions.
Oxidation would happen if you have enough oxygen. That doesn't require the H plus. If I have a sulfide and if I have oxygen, it will oxidize.
But at the deep ocean level, the dissolved oxygen is not in sufficient abundant quantities, so we need to remove the electron to some other species, and that electron we have shown the mechanism.
There is no, to be honest, there is no direct connection you can build with sulfate to sulfide about the acid water component. It's just too complicated. This can lead to a part of acidicity during the sequestration, but just looking the number of sulfate to sulfide, you cannot comment on the acidic part of it. So how this is going to be, okay, let's say acidic. How do you can infer about the FeHR by FeT ratio, the highly reactive to total iron ratio? How that will support or negate your answer?
So the FeHR is basically it is saying that the highly reactive iron is more in comparison to other parts of the world in the deep ocean. So again, because of the acidic conditions, Fe3 plus, which is the highly reactive iron, would be higher over there. So what we have, and we have also used.
We are not talking of speciations. We are talking of phases of iron, and phases contain both Fe plus 3 and plus 2, independent of where they are coming from, where they are associated with. Largely, they are independent of the speciations. So how the FeHR, the reactive iron, is linked to Fe plus 3?
If the iron is highly reactive, okay, let's say that the iron is in Fe plus 2. In Fe plus 2, it cannot react much because the oxidation potential of the iron Fe plus 2 to plus 3 is significantly higher. Now, Fe plus 3 to plus 2 in acidic conditions is a very, favorable process of reduction in acidic conditions, not in the alkaline conditions. So that we have explained using this ratio.
And what is your take on deep ocean organisms dying out?
So Fe3 plus is important for the biological metabolisms of the aquatic organisms. Now that the Fe3 plus is,
I can tell you that iron is a micronutrient, and most of the time mass extinctions doesn't happen based on micronutrients. You are mentioning about Fe+3 and it's a control in the ocean, but it's a micronutrient, you see. The major macronutrients are often the primary cause for any extinction.
Somehow these micronutrients are probably getting, attached to the macro.
Phosphorus out of the so basically one of the macronutrient that could play a role here is phosphorus. So I don't know exact mechanism by how iron would be doing this, but we believe that the species of iron could
You're connecting two different questions. FeHR and FET ratio is just a proxy to talk about a process, but we are talking now about a mass extinction and its causes that may not have do anything with iron.
but it can do with phosphorus in
It can do with phosphorus. You have to justify that then.
so the mass extinction is happening because of the glaciation. Major source of phosphorus is due to the land biomass, and due to glaciation the land biomass is cut off from the picture, so we don't get that phosphorus cycle, and phosphorus is not cycled to the deep ocean. But here it is mentioned that the second point, deep oceans near the continent seemed more affected by ongoing extinction. So to answer that thing, we explained that the above layer, the ocean above it is like actively being getting the macronutrients, so they are not they're competing over the deeper ocean, since that's what we try to.
Yeah, still not clear though. Okay, thank you. IISc, you mentioned about glaciation and no nutrient influx. So, can you tell me how? First, you did not tell about sulfate to sulfide ratio and water composition. Your answer was not.
Right, so I forgot to mention that. I am afraid I can't explain the initial values of sulfate to sulfide sequestration and the FeHR to FeT ratios. However, what I can explain is the changes that will happen. As I wrote on the board, this the particular bacterium that is now, particular microbe that is now proliferating
Why
in
do you
deep.
think that the conversion of sulfide to sulfate
Yeah.
will favor more 32? That was not given.
It's a redox reaction. The cell could be doing some sort of a
Why
reaction.
that will prefer 32 over 34 is a.
Oh, right. Because 32 has a higher reaction rates in lighter isotopes have a
I thought
higher
reaction
reaction
rates
rates.
are often linked to the electrons that is there in the outer shell,
No, but
which
in
is sort of
terms,
same for independent of 32 and 34.
no, but in terms of isotopes, it's easier for biological systems to consume lighter isotopes as it's faster for them, as happens in the
Oxidation is
case
not
of heavy
biologi-
water. Sorry?
Oxidation need not have to be biologically driven.
Yeah, but that is the assumption that I made, that in this case there are sulfide reducing bacteria in the ocean,
I can
deep
tell
ocean
you
that are
that this is
proliferating.
happening without biology. Can you rephrase your answer?
I'm afraid I can't. Like the entire thought process was based on bacterium proliferating.
Bacteria actually do the reduction.
Yeah,
It's a microbial bacterial reduction, we call it.
yeah.
So often they do participate more in the reduction part of it rather than oxidation, actually.
Yeah, this is a photosynthesis kind of a thing. Like we have sulfide being reduced to sulfur. That is something that being oxidized to sulfur. That is something that is well known.
Sulfate, you mean.
No, what we know of is sulfur. I am assuming sulfate could also be a possible thing. Like we have studied about sulfide being oxidized to sulfur. Yeah, green and purple bacteria.
And what is your take about the glaciation organism dying out?
Yeah, as I explained, glaciation.
You also
would
mentioned
upset-
like the iron thing. Iron is a micronutrient, not going to play.
Right.
And
My
also you
explain-
mentioned iron sulfate. That is also not very.
No, that's not iron sulfate. Those are two different things.
While talking, you mentioned about iron sulfate formation or stuff.
No, I didn't say anything about iron sulfate particularly. What I said was because those bacteria are oxidizing sulfide to sulfate, they would simultaneously reduce iron from its stable species to its reactive native species. That is what I hypothesize can happen. about the
That will
mass.
happen independent of the glaciation, isn't it?
Right, that bacteria could naturally do that. Where the glaciation kicks in is glaciation. We know ecosystems are they are very sensitive to external influences. So in this case, if the lack of phosphorus in deep oceans due to disturbance in the phosphorus cycle would disturb the ecosystem a little. This disturbance could be aggravated due to the proliferation of these bacteria, which could possibly thrive in low sulfur, in low phosphorus conditions, because we have this kind of heterogeneity, right? If a bacteria, a change in environment could give this bacteria what should I say, a survival advantage, and it would be naturally selected to blow up, sort of like a eutrophication at those levels, further killing the bacteria which were already suffering due to low phosphorus and stuff like that, outcompeting them.
Okay. I'll go back to Delhi and Kolkata. You guys said that you don't want to attempt that sulfur part. Why are recent pirates enriched in 34S? I did not get from you two. They mentioned about it. Kolkata is fine.
Yes. Basically, as it was already mentioned in the question, that the pyrite deposits in the shallow water region had high S34 by S32 compared to normal conditions. That means there the S34 is in a greater concentration, which is why since the pyrite formation in the deep ocean preferentially takes up the S32, so the S34 is left in the ocean for being deposited in the shallow regions. That is what.
Okay. Now what is your answer to that? Sorry?
Yeah, that was almost our answer too. That it was clearly mentioned that in the deep sea ocean, the S32 was preferably taken up for the pyrite formation, leaving the S34. So in near the shallow water, from where the sample they had only access to, comparative availability for the S32 S34 was more.
Okay.
Reading to the results
Thank you.
observed.
Thank you.
I don't have any questions. Thanks.
Yeah.
We would now like to request QMCs to present the correct answer.
So, hello. So it's given that in the shallow ocean regions, pyrite formation or the recent pyrite deposits have more S34 than S32 than normal. This is more so than normal. So what this means is that the water is lacking in S32 or has a higher S34 to S32 ratio than normal. So how this could happen? So from the information that given in the question, so pyrite formation in the deep ocean takes up S32 preferentially. So what could happen is that you could have a large amount of pyrite formation in the deep ocean, and this would take up the S32, leaving more S34 in the ocean. So one thing to note is that this is not Earth. This is on a different Earth-like planet. So what's given in the second point is that on Earth currently, you have more sulfates forming than sulfides. So what this indicates is that on this planet, there is something different going on that is causing sulfide deposition, or this is pyrite sulfide. So more sulfide deposition in the deep ocean. So I think a lot of you mentioned that the sulfide to sulfide sequestration ratio was higher than usual in this planet, which is not true. It's the other way around. The sulfide, it's more sequestered as sulfides right now, and that is the anomaly. So what we can see from that is that this is an indication of euxinic conditions on the ocean floor, which is anoxic and sulfidic conditions. So you simply don't have enough oxygen, so you don't form sulfates. So you have a lot of sulfides and
a lack of oxygen in the ocean floor. So FeHR to FeT ratio. So let's say we have some ion in a highly reactive state, some ion that is not in a highly reactive state. So how do you keep ion in a highly reactive state? You take away the things that react with it. So simply you don't have things ion for reactive. So this is again an indication of a euxinic condition on the ocean floor. So see, this supports the lack of oxygen. So the organisms are simply dying out because they don't have oxygen. So for the second part, you have a continental shelf, and then this goes down, and you have what? So this is given to be about 200 meters. So one thing that is given is that they are in an equatorial region, and the glaciation is not directly affecting these parts. So you don't have glaciers nearby. So you still have sediment influx from rivers. So the phosphorus input is not being reduced because of the glaciation here. So what the glaciation does is it takes away water from the ocean and puts it into land. So you have a sea level drop, which means what? You have a smaller area that is under 200 meters of depth. So if you look at it here, it will be a much smaller area because of a larger slope beyond the continental shelf. So what happens is less phosphorus is fixed. So the phosphorus influx has less place to be fixed. So it just goes down into the ocean floor, which means the organisms in the ocean floor now have a lot more nutrients. And this happens on like a relatively short time scale. So what happens is the productivity at the ocean floor increases, which increases oxygen consumption, and this is what leads to the anoxia on the ocean floor. So this is how it's related to the extinction event. Yeah. So deep oceans have oxygen. I think, I don't know if you remember, but there was a prelims question this year about oxygenation of the deep ocean. So this you have what? Open ocean region.
Louder, sorry.
Reason of the mass extinction was explained as oxygen concentrations going down in the deep oceans, which explains why there is high sulfur being deposited, sulfide being deposited over there, and high amount of iron reactive species, which makes sense. However, what I think is plausible over here is deep ocean creatures don't rely very heavily on oxygen like shallow ocean or land creatures. So should a decrease in oxygen be strong enough to cause a mass extinction?
So there are two aspects here. What he is trying to mention is, one, when you have a glaciation, you are sort of reducing around 200 meter the continental
that I
shelf,
understood.
so that part will be having one. And when you are talking of deep ocean anoxia or sulfidicity, you are not able to talk in terms of the 3,800 meter. You are often restricting yourself to sediment water interface, and that interface signals you can track with sedimentary rocks. And many of the sediment water interface, there are a lot of bioturbation and biological activity which happen in the benthos part of it, the benthic foraminifera and those things. They get altered if you change the redox state of the water, mostly if you drive them towards sulfidicity. Having lot of sulfide or H2S in the water column leads to poisonous situations where their survival is difficult. So that is what.
Okay, makes sense. Thanks.
Also, the deep ocean doesn't get oxygen from diffusion from the atmosphere. We have input like deep water formation near the pole. So it's not like the deep oceans are always anoxic. There is oxygen on the deep floor, and there are organisms that are aerobic on the ocean floor. So it's not.
So this part is, I don't know myself, so I'm asking. Deep ocean creatures, they don't depend on oxygen. Are you talking about only bacteria or
no, they do. But my point was their dependence wouldn't be as vital as that of low elevation ones, sorry, high elevation ones.
I mean, they are also burning carbon and producing carbon dioxide. Yeah, so
Right.
they need to breathe.
And respiration can depend on sulfur over there.
I mean, for getting energy, they need to burn oxygen, no? I don't know. only sulfide, bacteria and all there are some things, but
Yeah.
in general, deep ocean organisms, I don't know. I'm just
Ah,
asking.
right. Vertebrates and stuff. Yeah, makes sense. Makes sense.
This question is to IIT Delhi. Mama, a why behind you? Once upon a time, there lived two types of animals in peace on an Earth-like planet. One laid eggs with only a single semi-permeable membrane, call them eggs, and the other one had outer membrane, a sac of sorts, call them Y. Question 1. What advantages do you think X and Y could have had over the other in terms of reproduction and early survival? Answer in terms of environmental conditions. The planet initially consisted of a single large continent that was mostly rainforest. However, this would soon come to an end as the change in climate would replace the rainforest with a mostly dry environment. Second question. The graph below shows the connectedness between various populations of one of the groups before A and after B. This rainforest collapse. A higher value simply implies that geographically separated populations are phylogenetically closer. Identify whether the graph below represents X or Y. This is a frequency distribution with y-axis showing the number of pairs of populations against each connectedness value. Question 3. The graph shows the number of species in groups X and Y varying with time. Given that the drying event occurred a little before the vertical gray dotted line during the period marked K, identify which one represents X and Y. The x-axis spans about 100 million years. End.
Time starts now.
Do you need any clarifications? The time starts now.
If you explain it on the board, it will be useful to others also.
How closely related they are genetically, and you normalize it by the distance between. So you look at the how genetically close these populations are, and you normalize this by the distance. So you basically this is normalized by distance between populations. So if you have higher value, it means populations that are further away are genetically closer. So this frequency just represents how many pairs are at this value of connectedness. So it's just a frequency distribution.
5 minutes left.
One minute remaining.
IIT Delhi, you have 5 minutes to present. Your time starts now. Your time starts now.
Yeah, so X has a few advantages over Y. These are faster diffusion processes and they are better suited to survive in a resource lacking environment, and it also has a less resource intensive reproduction process. Y is has an advantage over X, that is, it is much safer from external hazards like other animals and weather.
So for the second bit, my claim is that the graph is of Y. So if we analyze the graph for the case before the drought, there was abundant resources available. So there is no problem. So they are less genetically connected. But after that, since Y can't survive in a resource lacking environment, they have a similar problem in which they will go, due to which they will go similar genetic mutation. So their PBC gets very high. And if we talk about X, X has already conditions such that they can survive in a resource lacking environment. So in the long run, they will not easily realize it. And so according to me, the graph should be of Y.
Right. For the C, I think the first graph represents Y and the second graph represents X. This is in coherence with a claim made for the first part, which is that X has a very high X is better than Y in reproduction. That can be explained by the graph before the gray line. And when we check the extinction, when we look at the change, like just before the gray line and just after it, we can see that in Y there is a decrease because the rate of diffusion of Y will be lesser than in X due to presence of an outer membrane, due to which it cannot survive in very, like, as we are just eliminating a resource, that is water, due to which its population will decrease, whereas in X it can survive in resource lacking conditions too because of its greater diffusion power. That's why there is a slight increase even though this event has occurred. So the first graph is Y and the second graph is X.
To add on to part B, I believe that there is another reason that supports why the graph might be of Y. So Y faces a much harder time during the rainforest collapse. So by natural selection, the ones that are the species which are in Y might go extinct, and the ones that are left are more closely genetically connected.
IISER Kolkata, you have 3 minutes to present. Your time starts now.
So like we have to tell the selective advantages of X over Y in the first case. So we believe that since Y is hard shell, as they mentioned, it would provide us more resistance from the external forces, and also it would take less water to form the outer layer. So since it takes less water, it can actively survive in the dry condition, and X whereas can be said to like actively let nutrients update. So we are trying to give an analogy where Y is laid by reptiles and X could be assumed to be laid by some sort of amphibians which lay their egg usually in water. For the second question, like we believe that this is the graph of X because we see that the population initially is very diverse, but after the stress or the external fluctuation, only few of the traits or few of the things are selected, and they increase in number. So after this, and from this graph we infer that none of the population is going extinct, and after time they are ultimately increasing. And if we look at the third case, we see that there is no initial population of in the graph 2, in the graph 1 there is no initial population in tau and which time period, which shows that the Y is evolved in a later time, like Y was not present in that time scale and evolved later. So since according to the phylogenetic tree we know that amphibians came after the egg laying organisms which laid egg in harder shell, we infer from this that the first graph can be y and the second graph can be of x. Just considering the initial population and how.
IISER has 2 minutes to present. Time starts now.
Okay, for the first question, I would agree where. For the first question, I would agree where X is an analog of amphibians, whereas Y is an analog of amniotes. X has an advantage in water-rich conditions where they don't have the cost of making the hard shell or the layered shell, whereas Y has an advantage in dry conditions where they can survive and reproduce better than X, which dry out. For the second graph, again, we agree that it's X because after the drying out event, the diversity, the connectedness increases, that is, the diversity decreases. So it's X because X is dying out and X is dying out and diversity is decreasing after the desertification. For C, we agree that it is Y and X respectively, but our reasoning differs. If we look at the graph properly, the first graph, there is an increase during period K when the desertification is said to happen. The first graph remains unaffected, so it has to be Y, which whose survival doesn't matter on water conditions especially. But for the second graph, we see a huge fall at K exactly, which corresponds to X as they are dying out. Also, just before the K event, we can see X were surviving better in the rainforest conditions than Y. Also, yes, their point about Y evolving later also stands.
IIT Bombay has 2 minutes to present their answer. Time starts now.
We can take the same analogy as X being for amphibians and Y being for reptiles. And X, because it has a semi-permeable membrane, it can stand the moist environment and helps in nutrient exchange much better. Y can stand in harsh and dry climates. It prevents the drying of the eggs in such conditions, and it also protects it from the predators. Whereas X, it helps in nutrient exchange in moist environments and where it is present in water bodies.
For the second question, we also believe that the graph is for X. Earlier, we can see before the drying happened, X must have been spread all through the rainforest, causing to have a wider graph. While after drying happens, we have been given that it's a mostly dry environment, but there ought to be some wet spots or some rainforest-like spots, which would be at a geographically separate location. So slowly X would migrate to these points and we'll see higher and narrower peaks because they're phylogenetically same, but the distance, average distance has increased. So the graph is of X, I believe.
For the third one, the first graph is for Y and the second graph is for X. As you can see, the fall in the population is not that much as compared to the second graph. That's because of the dry environment that has come into the place and the moist eggs are not able to survive. And the Y has evolved later than X, which can be seen as it comes from the third bar instead of the first one.
Also, before the drying happened, X were surviving much better, which corresponds to amphibians, which had an advantage in the rainforest conditions.
All right, time's up. Floor is open to questions from judges.
So the first question is to IIT Delhi. You felt that the second graph is for X. Can you expand more towards that? The second question, you said that it will be for X group. Can you defend that again?
So for the question 2, right?
Sorry, you said yes, it is for Y, sir.
Yeah.
You mentioned that this is Y.
Yes,
Sorry.
So our claim was that why couldn't survive a resource lacking environment. So because in the drought, since there is lacking of resources, so they have a similar problem. So they would get similar genetic mutations. So they would be more genetically connected after the drought.
And what will happen to X after the during the dry phase?
So X can for some time X can survive during during the drought, and in a long run it will slowly go mutations, but it would be, because it's a slow process, it would not be much similar, and so they would be not much genetically connected.
I did not understand your explanation. You were saying both of them will try to adapt and there will be mutations. And then you were saying one of them will be similar, another one will not be. Could you please explain once more? And also could you specify which resource, when you say resource, what do you mean by that? To clarification, please.
So the nutrients for making the eggshell, they are, water and nutrients for making the eggshells.
Okay, understood. For the mutation part, what is your, can
So,
you please clarify for both the species how they are mutating?
So why would face a very sudden problem? So they would have to genetically mutate in a very short period of time. So it would be.
Why is that? Why is the one that has two shells or two layers or whatever?
Yeah.
Why is the problem more severe for Y?
Because in the drought, Y requires more resources to form its eggshell oil.
Well, go back to Kolkata. You said that it will be X. So can you defend that?
We said that it would be X, the graph of X. So because we are considering a biological effect known as bottleneck effect, where when the species which is at disadvantage, when they force a natural pressure from the nature, you see that most of the species are disappearing, but few of them survive, and the surviving individuals ultimately make up the whole population. That's why we are seeing the reduction in the width of the graph, and there are fewer traits which are having more number of individuals.
But what about the values, which is much higher than what was before? So if you see the peak value,
But the overall area under the graph is same.
so what can be a scenario where a number of species gets magnified? I mean, you do
Okay, so in this case, assume a scenario where they found out a niche in the dry environment where they have no competition from other species after this stress. So they are like more in that particular niche. So the number also increased after.
you have a environmentally stressed condition, but still they can diversify.
Because that environmental, they can diversify or they can increase in number. So what do you want?
Increase in the number.
Increase in number. So that environmental stress would be same for throughout the whole species and all the competing species also. So there could be a scenario where after some mutations or after some genetic diversity, this particular species gets over the competition which it was facing from the other species. So other species could not evolve to the natural stress as relative to this one. So we see an increase in population also.
Please explain what is phylogenetic distance and what do you mean by it now? After this event, this particular one is coming closer. What does it mean? Just to understand what is it you are trying to explain in the first place? And becoming genetically similar,
it is mentioning about homogenizing of the population, because it is saying
in terms of what?
In terms of the genetic diversity.
Genetic diversity. So they are less diverse or more diverse?
They are less diverse.
Why is that?
Why is that? Because what is happening here is that as we increase the distance, what we expect is that they should increase in diversity due to distance. But here we are seeing that they're not increasing in diversity. There are only fewer set of population where the diversity is increasing with distance. So this is our argument. I can't get. Could you please follow?
Distance is remaining, getting smaller, even though the geographical distance might have remained the same.
That is due to the population being homogenized. So
What is homogenizing the population?
this particular selection is homogenizing the population, like only the individuals.
Do you think that it's easier to, build up a Y scenario where X completely wipes out and you have a Y situation, which is easier to build up higher in number or diversify in some way because they are more suitable for a harsher condition?
Yes, that could also be an wild. Yes.
Are you changing your answer?
So there can be multiples because these mutations are random events. So I won't say that they are equally likely, but yes, we could also consider that to be in the picture.
Okay. IISER Bangalore.
In the end, you want you require this whatever stress they are responding to, and for that they need to mutate. You were saying that mutation requires, makes all the genetic diversity go away, that or reduce. That's what you're. Is that what you're saying?
Not necessarily mutation. There could be few individuals which are existing with those properties, but in the dry condition, they get a chance to expand.
But they are existing in different parts of the world, and they are becoming similar. Anyway, okay, I understand. Thanks.
Yes, your take, please. You say that it is X. So.
Well, to explain A, because initially in the rainforest condition, X was able to survive better, it could diversify into several niches. More niches implies phylogenetic diversity. However, after the desertification, in graph B, even though some pockets of X were able to survive, those pockets could only survive in similar niches, and similar niches implies they adapt to the same conditions. Same adaptations come because they are phylogenetically closer, so their closeness increases. The other niches die out because the conditions that they survive best in are now gone.
Because these are diffuse niches,
Yeah.
how do you connect them? How they come together?
I didn't quite get you.
What is, or at least I am also trying to understand. I asked the same question to the previous group also, IISER Kolkata. Is it required to, a species across, geographically distributed to become genetically homogeneous to have similar mutation?
It's not necessary.
There are
but
two things here,
Yeah.
genetic distance and geographic distance.
Yeah.
How do you bring them together?
It's not necessary to acquire the same changes. It could happen.
So
that
then why
two-
should I
two
take your
bran-
hypothesis?
Yeah, well, it's chance factor. It could happen that two very separate branches develop the same mutation, but I feel it is more likely that the same branch, which initially
I feel like not agreeing with you.
No,
You have to convince me.
No, what I'm saying is these mutations in the case of the second one, in case if they were phylogenetically distinct, they'd have to acquire these mutations independently. Whereas what I am saying is, in the case of A, even there were some varieties of X that were suited to arid climates that probably could have come from the same phylogenetic group. It is these guys that survive and the others die out. I'm not saying that these mutations, because this is a very short time span. This is not enough for two or more distinct groups to acquire the same mutations. It is more likely that some people which had the mutations already,
Thank you.
Why it should not be Y?
it's a function of time. If we give it more time, in the same niches, we could see that happening. We could see more diversity even in those isolated niche, in those restricted niches.
For Y, you don't need isolated niches. They can survive in.
Why? I thought WHY. Sorry. For Y, their niches have in fact diversified, so they would rather shift from a graph like B to a graph like A, is what I propose. Yeah, because niches that were previously occupied by X are now empty for Y to go into them.
Can be possible that part of a Y is also, though they can survive in environmental harsh conditions,
Right.
but there may be few part of it which may not stay
Yeah,
surviving that. So you can go to A to B and with a higher number
Yeah.
with Y, which is easily possible.
We
Because the numbers
No, but the peak values don't correspond to numbers, they correspond to frequencies. So even though there is an increase in B, that's not an increase in the total population number, that's an increase in frequency. The area under the graph should be 1 in both of these.
Okay.
So narrowing should increase the height.
What is your take? You said X.
Yeah, we think that we agree with all of them that phylogenetic conditions
All
also,
of them has different view. So
I mean, like we had a major take that the main reason of this increasing is that the geographical locations of X would like kind of spread out, as I showed. They would be concentrated in some pockets which are not yet completely dry, and for Y this should not happen because Y can kind of survive in desert conditions also. So there is no reason for Y to be concentrated at some specific biological, some
Even if
specific
there is,
geographical
the
points.
conditions were very too harsh and there is no X at all.
What?
Let's say the condition is too harsh and there is no possibility of surviving any of the X. That is also one possibility, right? In that
mean,
case,
We have been
so-
given that it's a mostly dry environment, so the
Because-
conditions are not
because-
that harsh that it's.
also when you have a diffuse niche, the geographic connectedness, how do you establish that? When you have diffused niches, how do you connect them geographically?
I do not understand what exactly.
Each of the previous book, many of them say that it's this need to adapt. Need to adapt is making them similar.
Yeah.
Do you agree to that? Across geography, they're becoming genetically similar, and you're having a
Yeah,
bit
it
of
would
trying to understand if that is possible.
make
or not.
them
What
like
is your take on that?
phylogenetically closer, as they would the need to adapt would make them genetically similar, but
That's
still
possible. You think that that's the mechanism?
Yeah, that is possible, I
Okay,
believe.
Thanks.
We'd like the question making team to present the correct answer.
So, hello. I think the first question some of you did answer correctly, as in basically X is an analog of amphibians, Y is an analog of amniotes. So, X has a chance of drying out in a dry environment, so they need water to reproduce, to lay their eggs. While Y can like lay their eggs in drier environments, like they can survive with no water for their eggs. So that is A. So X has an advantage over Y in a wet condition because they will need less energy to like produce eggs. So they can like produce more offspring in one go. Then Y because they don't have to produce a shell for their eggs. And Y obviously has an advantage in drier conditions. So going to the next one. So obviously you have a plant with mostly rainforest and it goes into a place with mostly dry conditions. So you could have like grassland or whatever. So essentially you have a situation where it was advantages for X and you go to a situation where it's advantages for Y now. Right. So yeah, so this is right. So you have, this is a continent and now, okay, I'll draw. This is mostly rainforest. And now you're like transitioning to this state where this is like dry and your rainforest is becoming fragmented. So what essentially happens is before all these areas were accessible to X. So X could survive everywhere. But as this happens, the areas where X can survive become smaller and fragmented. So I think a lot of you came to the conclusion that this would lead to a higher connectedness value for x. I think the problem here is that your first assumption is that these x's would end up having similar mutations later on, which is not true. They are like separate populations. They are not going to have the same mutations. They will be, if these conditions are similar, they will end up having similar phenotype, but they will not be phylogenetically similar to each other. They will be genetically different. And I think the other thing is that you are simply taking x from being here to being in separate population. So you are just taking the existing x's here and just distributing them over here. So this doesn't, rainforest doesn't collapse over a single generation. So this will take several generations, and once these populations are established, they can't really connect with each other. So it will be, so x cannot really have a higher connectedness after this collapse because their populations are isolated now. They cannot connect with each other. Now for y. Y was in the situation where they were in a disadvantageous condition. Now they're moving to a condition where the most of the region is advantageous to them over x. So there is two things. So this was a rainforest. Now this is open. So first of all, this is a more open region, and secondly, this is advantageous for them over y. Over x. So you have an area where you don't have x and it is also open. So this will lead to better connectedness between population. So if you look at this situation, y will have a different time traveling between, like populations will have a difficult time migrating from one place to another here, but not so much here because this is an open landscape. Y can move around, but x cannot move around. So that is the second question. So the graph is of y, not of x. So the third one, again, I think a lot of you got it right. So at k, this one. So at k, x, the second one sees a huge drop because of the drying event, while here nothing is seen. So the second one is x and the first one is y. Yeah. Oh, okay. I will answer your question third time. Let's wrap this up.
With that, we would now like to conclude the final round for ECS Mimamsa, and we thank all of you for attending today.
Now we will sit. Once again, I would like to thank our judges for the round. Now I would like to request so we have lunch ready in the area adjacent to the Shiv Sagar mess. So I would request the team coordinators to escort their teams to that area, and also after the ECS question making team and the judges have had their discussion, the ECS question making team and the judges can also proceed to that area for lunch.